Now that was collinear relative motion, where we have everything or all the directions of motions, velocities, and displacement on the same plane, like on the x-axis or on the y-axis. Now what if we have a certain object moving on the x-axis, another object moving on the y-axis? If you remember, that's what we talked about in more details in Victor's components. Let's suppose that there is a jet traveling west that encounters a crosswind of 56 kilometers north. So the airplane traveling west at this magnitude, and the wind is traveling 56 kilometers to the north. Now, what is the v ground, or what is the resultant speed in this case? So what we do, we draw a Cartesian, if you remember, then we plot those vectors. So we have v air to the left, or v airplane, and we have v wind to the north, and the v ground would be tail to head. Now, in order to know the direction of the v ground, we need to find theta. And if we want to know the value of the v ground, we just take the square root of vx squared plus vy squared. If you remember, that's v air squared plus v wind squared, or vice versa, v wind plus v air squared. That would give you 791 kilometers per hour. That's the value of v ground. What is the angle of v ground? We say tan theta opposite over adjacent. Opposite is 56 over 789. That would give you the 0.07 tan theta. Then the theta would be tan inverse of 0.07 would be 4.1 degrees, in this case northwest. Now let's take a full example on the non-collinear relative motion. For air would be a plane flying west with an airspeed of 789 kilometers per hour. Find the direction of the plane that have to fly to compensate for a wind velocity of 56.3 kilometers per hour north. So we have wind going north, and we have the airplane is going with an airspeed of 789 kilometers per hour. How would we find the direction? In this case, we want to find the theta. So we go to Cartesian. We draw our vectors. We have the v wind and we have the v air. Now that's the angle we're looking for, since we're having tail to head as the v ground. So we're given v wind, we're given v air, and we know that the direction of ground velocity is west. So what is required? We need the plane's direction, or the theta. First, we make a diagram based on the defining equation v ground equal v air plus v wind, and we say the sine theta opposite over hypo. The theta in this case, sine inverse opposite over hypo, that would be sine inverse the 56 over 789 equals 4.1 degrees. Why we didn't use the tan theta? Tan theta would give us opposite over adjacent, would be v wind over v ground, but we don't know v ground, so it makes sense to use sine theta, which is opposite over hypo. We know the hypo as a v air, we know the opposite as a v wind, so those are given to us, and that's how you get your theta. Sometimes you could need to use the cosine theta, so you need to be flexible. Either use tan theta in most cases and sine theta sometimes. Cosine theta is less famous to use, but it is possible to use. What is the ground speed? You know that. V ground would be v air squared minus v wind squared under the square root. Again, all of these are changing than what you used to see in equations, because the v ground in this case is the adjacent. It's not the hypo anymore. So you need to be flexible with that. So the v ground would be in this case 787 kilometers per hour. In many cases, you will be asked what is the time needed to travel at that certain speed, or the v ground in this case, from location A to location B. In this question, Toronto to Edmond. He would give you the distance between Toronto and Edmond, and he tell you how much time it needs to reach from this city A to city B using your v ground that you found in the question. In this case, you use this equation. Delta T would be equals delta D over V. Delta D means the resultant in this case, and you're given delta D 2335 over 787, and that would give you 2.97 hours. Why we say hours? Because we are using kilometers for distance. We're using kilometers per hour for speed in this case. If it was kilometers per minute, then it would be the time in minutes. Another example, this case, we have a boat on the river. It's not an airplane in the air, but still, all same concepts apply. Edmonton Queen paddle boat travels north on the river at a speed of 5 knots or 9.26 kilometers per hour. Knots is a unit to measure the speed of wind. Wind is pushing the boat in this case, I would say. So his speed is 9.26 kilometers per hour. If the ground velocity is 10.1 kilometers per hour on 23 degrees east of north, what is the velocity of the river in this case? Let's draw our vectors. We have the velocity of the boat and we have the velocity of the current or of the river. We need to find V ground. Now, V ground in this case is given to us and V boat is given to us. What we're missing is the V current or the velocity of the river. So the V boat, 9.26 kilometers per hour, and the V ground in this case, 10.1 kilometers per hour with a degree of 23 northeast. We have the V ground, and we have V ground Y, and V ground X, and we have the V boat. Now let's do the X direction analysis. The V ground X would be V ground sine theta, V ground Y would be V ground cosine theta, 3.94 for V ground X and 9.29 for V ground Y. So the boat in this case is moving north, so his Y component is 9.26 kilometers per hour, but the X component is 0. There is no X component for the boat velocity. So V ground would equal V boat plus V current. V current would be V ground minus V boat, and V current X would be V ground X minus V boat X on the X axis. And V current or V river Y would be V ground Y minus V boat Y. In this case, you found the X and Y, did the summation for X components, Y components. If you remember from the vector components, the V current would be square root, as I mentioned, of the X component squared plus the Y component squared. And that would give you 3.946 kilometers per hour. What is the direction of the river velocity? Tan theta, opposite over adjacent. We have the opposite and adjacent, so we keep the tan theta as it is. Theta would be tan inverse of those values. That would give you 0.5 degrees. So the river velocity is 3.9 kilometers per hour, moving 5 degrees northeast.